And thank you, Sujamam. Thank you, Ashish. Thank you, Prashant. Thank you, Sharayu. Thank you, Jiva. Yes, great. So now in our previous session, we have covered our 7th module, the initial portion of it, which was more to do with nonce. Is my audio clear? If my audio is clear, type A in the chat box. Yeah, thank you, Ashish. Okay. So for the people who have recently joined, right, I'm going to guide on to like how to go about joining the session, how to navigate yourself through hackathons, and also through the actual lectures and session, right? So how many of you joining us on social channels or Zoom can let me know? If you can let me know if you've joined in the recent month, like in the past 1 month, type me in the chat box. You joined in the past. Thanks, Sushant. Thanks, Vijay. Thank you, Sharan. Okay. So I hope because Sharayu, I have seen you in the past. The Sunday only joined. Okay. So welcome, Prashant. I would also request you to join today's 8 p.m. inner circle as well, right? So I'll definitely that would be more of for you kind of an introduction of the whole flow and the walkthrough also, right? So thank you so much. Right, let me go ahead and share the screen, and I'll point you on Teachable and how to go about this. Okay, so I hope my screen is visible now. Yeah. So now, if you open your Teachable, just opening the Teachable, you might you might be having the access to the same, right? So this is how your curriculum will look like. I'm just going to open it. Yes, Sharai. Thank you so much. So now if you look at your lectures, like if at all you are in bronze, you'll have a few modules access, and if at all you're in silver, you'll have the whole access that you'll be able to see. If at all you're in gold, you'll have even more modules. Apart from silver, you'll also have more modules accessible to you, right? So now if at all you see, we have covered all of these sessions in revision hackathons. The format of revision hackathons is in this way. The actual lecture is covered by the primary faculty here, Professor Pandurangan sir. So he'll be covering he has already covered all of the live lectures and everything. So as we proceed forward, what we are going to do is we are going to revise each of his lecture, right? Sometimes a whole of the lecture in one hackathon, or break it down into 2, right? So in that fashion, we have completed from 0, and currently we are in the 7th module, right? So do not worry, you are not missing on the live cycle. So what happens is, after we finish 10 modules and also the solidity modules, we are going to start from the beginning, right? So you can even join back again, right? First, I would request you to go ahead and start from the beginning as well. So you can even choose to be part of this while you are coming from the beginning, right? So what happens is when you come this particular session, that particular module, the actual lecture will become easier for you, right? So this is one way. The other way is all of the revision hackathons lectures are also, the recordings of that will be available in your inner circle towards the end, right? So what you can do is you can go through that recordings also. You can go through the actual lectures in the bronze or silver or gold course, and then you can go through the recording parallel. For example, if module 3 is complete here, you can go through the module 3's revision hackathons recording. So this you can choose based upon your choice, either finish the live lecture, the actual lecture and the hackathon recording, or attend the live hackathons while you're parallelly coming from the beginning, right? So any which way, it is fine. Okay, so do not worry, we're going to start from the beginning once we finish the cycle, right? If at all you have any other question, for example, you are in first, second module, third or fourth module, if you have any question, you can even bring that question to us in the hackathon, any hackathon, and you can ask those questions towards the end so that we'll be able to help you, right? Apart from this, you might have already joined the Mighty Networks community. What you can do is, if you have any other queries also, you can just go ahead and put up that query on the community as well, right? So other members or we ourselves will be able to help you immediately. Great. So I hope that is clear. And in our previous session, we covered our module 7's initial topics. Now we're going to begin from where we have left off, right? So I'm just going to quickly revise what we have done in our previous session, right? So I hope the instruction, especially Prashant, because this is the first session, I request you to join today's 8 p.m.'s inner circle call by Jain sir. And also, if you understood, the instruction of what is a hackathon and how it goes in hand with the actual lectures, if you understood that, type you in the chat box. Yeah. Thank you so much. Okay. Right. So in this particular session, so what we're going to do is we're just quickly going to revise. So in our previous session, we have understood in the blockchain, we have gone through each of the blocks, right? So what elements a block has and what is the size of each of them in bytes, right? So a block has its header, a few variables or elements where more value is added, and transactions also. So you understood that. I'm just going to revise, not going in depth again, right? And then each block is going to have a block header, and block header is of 80 bytes. So we also understood what all things are covered in this 80 bytes, starting from version number to the hash of the previous block, the difficulty target, nonce, timestamp, Merkle root. In 2 sessions before, we have understood little about Merkle root. In the previous session, we have understood about nonce, right? A little about difficulty also. We'll cover from the difficulty today. And then we have left one question unanswered in our previous session, which was how to calculate the threshold and how it is set and how it is updated, right? So in today's session, we'll learn more about this threshold, right? So these are for people who have recently joined. These are like actual screenshots from Professor Pandurangan's lecture. So you can, while you're going through the lecture, he's going to, write and, you can also learn from there. So these particular presentations will also be available on your inner circle, right? So we also tried understanding how all these nodes communicate with each other and stay in sync, right? So then we try to understand, because there are so many nodes, how will we know that when there is a winner in the mine, a miner is going to win it. And so there are many people who are trying to mine. And how do we know that who has the authority to generate the block? And how can everybody agree on that? How can there be a consensus among all the nodes, right? So that is where we have, tried understanding more about nonce, right? So there, nonce was one value where let me just go through the nonce portion. Okay, so we have understood probability, then we have understood what is nonce, right? So it is one value which when concatenated with the actual transactions hash, right? So actual transactions, and when the attempt that the person is making, the number that he's finding, when he is going to add that value along with the transaction and hash it, if that hash value is less than a set threshold value, then that person is going to be called as the winner. So in this particular example, if we see, let's say a person is hashing all the transactions in a block, let's call that M, and at one particular value, say this random value, what was this, 79 crore 85 lakh 60,000. And so some random value, he was able to have the whole of his hash less than the threshold, right? So then when this condition was met, that particular person becomes the winner. The first person to do that becomes the winner. Yeah, so Jiva, how is this going to happen is Professor Pandurangan sir has taken all the lectures. We're going to have multiple faculty who is going to take the revision hackathons, right? So because the contents of the lecture do not change. So the actual lecture is with you. So you can go through the actual lecture for queries and understanding. And, there are multiple faculty who will come along and explain or clarify your queries, right? So that is how this will go. And if at all you need anything, right? For this cycle, I'm taking this particular cycle of the blockchain revision hackathon. If there's any query also, you can always reach out to me, right? So I'm just sharing my details with you. Yeah, so you can always reach out. Great. So this is what we have understood. Thank you so much. Okay. Just share the details. Okay. So now as we have understood, now nonce is a 4-byte value. 4-byte, it is going to have value of size 4 bytes, which means it could accommodate up to 2 power 32 values, right? So which means there will be 410 crore values only for like nonce, like how many values that could be. Out of that, when one particular random number matches the condition where hash of all of it is less than a set threshold, and the first person to do that becomes the winner, right? Thank you, Prashant. Now, so the probability of hash value being less than value t is what we have understood in our previous session, right? So in one of our examples, like the probability example, if there are like, what is the probability of 2 people being picked out of 32 people is going to be 2 by 32, right? So that is how we have done. So similarly, if the t is not known, out of 2 power 256 values, that can be the actual hash values, because hash it is a 256 byte 0 and 1 256 bit 0 and 1 binary number, right? So if you are converting it into binary, what happens is there'll be 2 power 256 hash values that are possible. So the probability of it being less than t value t, let's say if it is less than, let's say 1 crore, I'm just giving a random number, if 1 crore by 2 power 256, right? So the favorable number of cases by total number of cases. So there could be total 2 power 256 hash values, and out of the chances of the probability being there, right? So how many, if less than 1 crore, be 1 crore by 2 power 256. So it's just a random example. We have seen this in our previous example, which was this, right? So expected attempts for an event to occur. Let's say in this particular example, if we have to pick 2 girls out of 32 size class, it will be 2 by 32, which is 1 by 16, right? So the number of expected attempts will be 1 by the whole probability, 1 by 16. So the expected attempts is, out of 32 people in the class, if 16 attempts can be made, the chance of getting one name out of that being a girl's is 16 attempts. So you'll have to make 16 attempts to get that particular value. So this is what we have understood previously. So the t can be called as threshold, right? So now this is the the visual value that you would want to understand, like when m concatenated with nonce less than threshold, the hash of it when it is less than threshold, then the first person to achieve this will be the winner. Now in our previous session we have seen about nonce, and today we'll see about the threshold, right? Now this is what we have understood, and then we also understood one value called the level of difficulty, right? So because there are 2 power 32 values that could be fit in for a nonce, right? So it would be for one person to exhaust all the attempts, like 2 power 32 attempts, is going to be the whole difficulty. So that is 1 unit of difficulty, right? So I'm just going to explain that. So now, for example, if T is going to be the threshold, the chances of it being less than threshold, the hash value is less than threshold will be this, right? So it being in this. Now, these are a set default system parameters. When Satoshi Nakamoto time, then only when the system, the whole blockchain system was made, then a set threshold, like a value was set, which varies, right? So we are going to learn more about threshold today. So in our previous session, we ended here where the threshold was, if it is 2 power 224, the number of attempts that a person has to make is 1 by 2 power 32. Right? So this is what we have understood here, right? So the probability of the hash value being less than this is T by 2 power 256. And now we know that the probability would be 1 by 2 power 32, right? So it's a very small probability that a person will be a winner, right? So 1 by 2 power 32, like 1 by 410 crores is a very small probability, right? So the person being a winner is a very small probability. And if he's exhausting all of his 2 power 32 attempts, he'll have to do another cycle of attempting hashing the whole transaction, right? So this 1 by 2 power 32 is called 1 unit of difficulty. Like, for example, in our this case, this small example case, we'll try to understand here. If there is a jar where, there is a jar where there are 32 names are there in different chits. If at all you have to find one of them being a girl's name is 1 by 16, right? Chances are you'll not find it in the first attempt, right? So every 16 attempts is going to be 1 unit of difficulty, right? So if at all you have not achieved in for the first 16 attempts, you know that, okay, the chances of it being there in 16 attempts is there, but there's a chance that it will not happen at all, right? Even not happen in the 50th attempt also, right? So if you're going till 50 attempts, you have completed 50 units of difficulties, right? So the unit of difficulty 50, you did 50 units of difficulty, right? So that the 50 units of work there, right? So if the unit of difficulty is clear, like this 2 power 32 is clear from our previous session, right? Type C in the chat box, where a person has to do 2 power 32 attempts in one cycle. Then there are chances that he'll find one hash value which is less than threshold. If he's not able to find, he has to start again, right? So if you have understood that, type C in the chat. Thank you, Sujama. Yeah, so I hope it is clear for others also. Right? So 1 unit, 1 cycle, you being exhausting, like, that particular is going to be your unit of difficulty. For example, if someone says, the difficulty right now is 10, right? Which means 10 into 2 power 32, right? So because 10 times that the person has to, do that particular thing to actually achieve the hash value of the whole transaction being less than the threshold, right? So now we'll understand in today's session how the unit of difficulty is dependent on a few other variables, and now it will become more clear. Now, if you have briefly understood also what is unit of difficulty, now it will become more clear today, right? So this is what we have previously understood. So now what we understand is, like, for example, the same example, if let's just say there are 100 values and the threshold is 25, right? If threshold is 25, the probability of a person, like an event occurring which is less than 25 is 1 by 25, right? So that is what that will come. Now what happens is, if let's say the threshold is being reduced, right? If it is made 5, now what is going to happen? It being the favorable cases are 5 by total amount of cases 100. Now the probability will become 1 by 20, right? So this is how it will be. Like when, if it is the threshold is 25, the number of favorable cases would be 25 by 100, which will be 1 by 4, right? So now, whenever you are reducing the threshold, your probability is, your difficulty is increasing whenever you are reducing threshold. For example, if the threshold is 50, if you're increasing the threshold, there is, 50-50 chance, like, the difficulty is reducing, right? So if you're with me, you've understood that whenever the threshold is decreasing, the difficulty is increasing. If you've understood this, type U in the chat box. Right, so we'll go by the example also. Yeah, thank you, Sujama. So I'm just going to explain this once. Now, for example, let's just say earlier the threshold was 25. Now, when it was 25, the probability of event happening was 25 by 100, which was 1 by 4. It comes to 0.25, right? Now, when it comes to, when the threshold is reduced further, like now if say the threshold is going to be 5, the favorable cases by the total cases is 1 by 20, right? So which means 1 by 20 becomes 0.05. Now you can see that the probability from 1 by 4th reduced to 5% only, right? So what happens here is, whenever the threshold is reduced, the difficulty is going to increase. So now if this is clear, you can type U in the chat box. Thank you, Sujama. We are clear there. Okay. Thanks, Vijay. Now, whenever the T is decreasing, the difficulty is increasing. Now, for example, what has been set, right? In our previous session also, we have seen that for a person to generate a block, the system parameter, it was actually said that it will take 10 minutes for any miner to generate a block. So it is not said, it is like a calculated mechanism where any person who's generating a block is going to take roughly and on an average 10 minutes. Okay, so Ishwaran sir, like, so I'll ask the question: what is the use of nonce, and how do I find or get optimum nonce for my mining? Right. So I'm just going to clarify that. We have covered this in our previous session also, but just to make it easier, I'm just going to explain this. Now, so the nonce was a value. It is not like an ideal nonce. So this is very random. So nonce is number that can be used once, right? So number that can be used once. So it is going to be just a number. There's no optimal nonce here. It's going to be an attempt number. For example, what is happening is, if you take the 32, picking 2 persons from 32 example, right? If that is the case, your nonce would be like, for example, if you are able to get it in the let's just say 10th attempt. Now your nonce, that attempt here would be that nonce, right? So a person coming from 0, like for example, this is the first attempt he is making, and he is hashing the whole transactions, and his nonce, the number of attempt that he made started from beginning, and it was the first attempt he made. And say his value was greater than the T value, right? So meaning this condition was not satisfied, right? Then he increases his nonce, right? He says, like, let me try for a different nonce number. And he checks, because the probability is very low for him to be successful, for him to generate a value which is for a nonce value, which will give him a hash value less than T. The probability is very low, and for that reason he'll keep on doing that, right? So there is no optimum value. If it was easy for anybody to go ahead and calculate nonce, like this, the chances of the nonce being in the first 1/10 of this, and if there was a calculation like that, people will do that. So this process is very random. Yeah, so there's no one way to find an optimal nonce. It is going to be like a random number generator. So whenever it's like a roll of dice, so you're just trying to achieve the condition. Like say right now you want 4. Now you are going to roll it until you get a 4, right? So that is how it will be, Ishwaran. So there's no one fixed way to get an optimal nonce, right? So you have to do the work, right? So that is the whole systems plan, is that it wants every miner to do a certain amount of work, right? So that is what this is. I hope that is clear, sir. Thanks for the question. Right. So I hope it is clear for everyone also. If it is clear, type C in the chat box. Great. Thank you so much. So now one block, it is said that, thank you, Suju ma'am. Thank you, Ishwaran. Now one block on an average to generate a block, it will normally, for a successful person, for a miner to validate, do the block computation, to verify, to validate and extend the blockchain, like add one block, and then the confirmations will start flowing, right? So to create a new block, it will at least take roughly 10 minutes for a person, right? So now for a person to, because for creation of every block is going to take 10 minutes. So this is going to give us a little clarity on the equation. So we know that the block creation should happen within 10 minutes, right? So this is the average. So if anybody asks like, what is the average time for a block to be generated and added onto a blockchain, it is going to be 10 minutes, right? So now we know this value. So this was set in the initial setup when the genesis was happening only, right? So as we go forward, they have calculated, because they had the assessment, they understood that many times the creation or generation of the block happens faster also, right? But on an average, because the system computation capacity of different people is different miners is different, and based upon taking of all these parameters, the average time is going to be 10 minutes. So this has been set, right? And there is a way to they have made a very good system, which Professor Pandurangan sir in the lecture also says is a very genius system that the people have made to keep that block generation time for 10 minutes. So whenever the system was being created, what was made sure is each of the member should be able to go ahead and put in definitely 10 minutes of effort. So that is what been set in the initial time, right? Yeah, so Ishwaran sir asks a question. Can you please tell me how do I avoid earlier attempted value? So there's no specific system, sir. There's no other way. So when you are doing an attempt, you're not aware of other person doing the attempts, and that is where the competition comes in, right? So if at all you want to not do the attempt, let's say, for example, you do not want to do the same value you tried before, there is a way where you will record all of your nonce values, like how many attempts you have made, how many cycles you have made in your block, right? So we have also mentioned in our previous. So there will be the first code-based transaction where you save your attempt. Like, for example, I have done so many attempts, and that is being recorded for your own understanding, right? So you will not be able to see other person's attempted values. So how do I avoid earlier attempted values, M plus nonce, in this process? So I think you are already clear that you'll not be able to see other values, but for you to know that what values you previously attempted, there is the code-based transaction, which is of 100 bytes, right? So this is what this was. So there is one code-based transaction which does not have any inputs, because that is the first transaction in any block, which is empty. So which has some space for you. So you record all of your nonce counters and everything here. You can do that. I hope this answers it. Great. Yeah. So now this is there is a way that the system mandates every person to actually put in effort of amount 10 minutes, right? So that has been already set. So now how is this being achieved? We'll see that. We'll also see an actual use case. Thank you so much, sir. For everyone to have a common blockchain, right? So now it is going to take 10 minutes for everybody to be aware that there is a new block that got created, because the block computation is happening, verification, validation, extension of the block, and new confirmations. So every 10 minutes, all of the nodes on the blockchain will be able to see that there's a new block that got created. And this depends on something called hash rate, because how do we know that every block is spending 10 minutes, right? For example, now the calculation of the nonce, right? Here, what is our calculation? The whole of our calculation is this, which is the calculation of hash. So if we know what is the hash rate, right? So at what speed a hash is being generated, if we know that, it will be easier for us, because we know the in 10 minutes, one block has to be created, one block has to be generated. Then if we know how fast a person is able to hash it based upon his computer speed, there'll be a hash rate, right? So now we'll try to understand the hash rate. The number of hash operations you could do in 1 second, right? So this is the hash rate. So there is a system average hash rate also, right? As the computation time increases, right? So as the computational power increases, like for example, a few years back, the computation power was different. Now it is different, even for regular systems. So the hash rate will increase naturally, right? So the average hash rate of the whole, recent blocks is always calculated. We are also going to do a practical of that and see. So if you've understood what is hash rate, which is the number of hash operations a miner or a person could do in 1 second, if you understood that, type U in the chat box. Yeah, thank you so much, Sujama. Thank you, Prashant. So Ishwaran sir asks, Coinbase is part of the mining software. So basically, if you are attempting mining, every transaction will have something called inputs and outputs. And okay. So Rahul sir, if at all you're new and you recently joined, do not worry. I've just given the brief to all the new members. So how this is going to happen? This is like a revision hackathon. You do not have to worry. This is one cycle that is happening. Now we are in the 7th module. So definitely it will be Greek for you because you're parachuted into it. So you can start from the beginning, right? Towards the end. Also, I'll be able to guide you on how to start from the beginning. And if you have any queries, you can bring that to the hackathon live session also, right? And once we finish all of this series of hackathons, like for 10 modules, we'll start from the beginning, right? So for you can strengthen your concepts again while you go through the actual lectures covered by Professor Pandurangan, and also joining the hackathon sessions. If at all you want to continue currently also, the live lecture is there on the Teachable, and the recording also will be available on the Inner Circle, right? So I'll be able to guide you if there's any query that you have, sir. I hope this helps. So do not have to worry. Okay, I think the access to Professor Pandurangan sirs has been shared over. If at all you have a challenge in accessing the Teachable, I'll guide you towards the end, sir. Do not worry about that. Right? So because if you have received the email of today's session, meaning you are already in the system and it might have been triggered, but we'll check it towards the end, right? So if there's anything also I've shared, the way to reach out, you can always reach out and I'll be able to help, right? Okay, thanks everyone. Now hash rate is clear, thanks. And now the work the system wants a miner to do is 10 minutes. That is also we have clearly understood, right? So especially today's session will be a little numeric and all, right? So if at all, there are many sessions where we go into more conceptual and theory based, but today it will be a little this thing, very little, right? So now we know that the expected number of hashes one would do if t is set as the threshold, right? Now we know that it takes how much time for a person to put in all the work to generate a block. It takes 10 minutes. So a new block gets created every 10 minutes. 10 minutes is nothing but 600 seconds, right? 60 seconds into 10. We have got 600 minutes. Now hash rate. Hash rate is the current performance, or the the rate at which one the hash is being generated per second, right? So that is that is what we have understood here. Now we also knew in our previous session that previous things that the expected number of attempts or hashes one can do is 2 power 256 by t, right? So if you remember, the probability of the hash value being less than t is t by 2 power 256, and the number of attempts required would be the inverse of that, 1 by t by 2 power 256, right? So which means 2 power 256 by t, right? So let me just go ahead and take you there. So if at all you have missed the previous session only, right? So if you're not new but you've missed the previous session, the recording of that will be available. All of these recordings are available, not worry. Right. So now we have seen that the probability of the hash value being less than t is t by 2 power 256. Right. So this is clear. And the expected number of attempts, is the how many attempts you have to throw a dice to get one is 1 by p. And so here the probability was t by 2 power 256, which means the number of attempts that would be required is 2 power 256 by t. So this is how we have achieved this, right? So now we are clear. Now, Professor Pandurangan sir writes on the iPad, so it is easy to write then and there itself. I have to do a little back and forth, so do not worry. Okay, so now we have understood this. Okay, now this is clear. Now, the number of attempts is this, which is also the number of attempts is the hash rate into 600, right? So now we know that from this you can generate the t value, right? The threshold that we wanted to understand today was t equal to 2 power 256 by 600 into the hash rate. Okay, so now if you have understood this equation that we have made here, type u in the chat box, right? If people who have joined recently, if you have briefly also understood, you can type u in the chat box, right? Okay, thank you so much, Suju. Right, so now we have got the three, this is the equation. Thank you, Ishwaran sir. Even people who have recently joined are able to understand. That's really great. So now threshold. Yeah, so if people who are not able to understand, do not worry. Okay, so there's all the recordings are there, and you can start from the beginning of the teachable, right? Not worry. But one thing that we know that the hash rate is different for different people, right? So a low performing computer might generate a lesser hash per second, but then there are supercomputers. Even Professor Pandurangan sir explains supercomputers which will have a higher hash rate. But what the system requires is, if somebody has a higher performing PC, he will be at an unfair advantage to mine more and earn more block reward, right? He can earn more block reward or this thing. But the system wants everything to be fair. So how do you make this fair, right? So how to have threshold value that is self-adjusting and depends upon different hash rate, irrespective of the performance of the system. Everybody should put the same 10 minutes, right? So it should be not like if somebody has a higher performance system, he'll be able to hash it. Like for example, he'll be able to do some million transactions, million hash value calculations and find something less than t, and he'll be able to do that in 5 minutes, right? So the system does not want that. The system wants each block to be generated after at least 10 minutes, right? So around 10 minutes, meaning everybody has to put the same effort, even if it is a a supercomputer or a regular person, right? So now how do we know that proper threshold is set based upon a variable hash rate? So this is the challenge that we have, and this has been smartly addressed in the system, right? So now let's understand, as we have seen previously, if the difficulty is 10, right? So now difficulty is what? The 1 unit of difficulty we have discussed here was 2 power 32, meaning it will take 2 power 32 attempts for a person to exhaust all his sequence of all his nons and then restart, right? So this is what we have understood. Now when we say difficulty is 10, meaning 10 times 2 power 32 attempts have to be made, right? So now what we try to understand is, if we know the hash rate, we'll be able to set the difficulty, right? So a hash rate depends upon the difficulty, and the difficulty depends upon the threshold, right? So if you remember the 125 and 5 example we just now taken, now once we know the threshold, we know how difficult it is to find a particular value or match a condition, right? So we know the difficulty based upon threshold. If we know the difficulty, it will become easier for us to know how much work has to be done per system or per node, right? So this is what we have understood. So we are trying to understand threshold here. Now we are trying to slightly bring the relation between the hash rate and the threshold and difficulty, so that we'll come to a clear picture, right? So if you're clear till now, so what is happening this equation, if you're clear till now, type C in the chat box. Thank you, Suju. Thank you, Ishwaran. Okay, so what T we select? So there will be 600 into HR attempts, like hash rate. So we want every person to spend 10 minutes, so based upon their own hash rate. So how do we have a T value that will see that there will be so and so many attempts in that particular block or that particular miner's system, right? So now what we are trying to understand is, now threshold, what they have done. So how they have come to a calculation is, they have first taken an average. So what they have done is, they have understood the time taken to generate 216 blocks, right? So random, like from the initial time only, they have seen how much time 2016 blocks are taking, right? So they have tried to assess that, and they are going to reset the threshold value. The actual threshold value that we have seen is T power the 2 power 224, the system parameter, which keeps setting. Like if the threshold, if it is becoming easier for people to calculate the hash value, it is going to increase, decrease the threshold. If it is becoming difficult, it is going to reduce the threshold, right? Because difficulty and threshold are like invertly related. Like as we are decreasing the threshold, the difficulty is increasing. Like to make it easy, threshold will increase. To make it difficult, threshold will decrease, right? So now if the default say is 2 power 224, the time taken to generate 2016 blocks, which takes, like, let's consider every 10 minutes, so every hour there are 6 blocks getting created, because 10 minutes 1 block is getting created. So in an hour there are 6 blocks getting created. In 24 hours, how many are getting created? In 2 weeks, how many are getting created, right? So now what we understand is, it takes 2016 blocks 2 weeks to all get generated. So this is the actual figure. So now if you understood that the time taken to generate 2016 blocks is 2 weeks. Now, if you understood that, type U in the chat box. Thank you, Vijay. Thank you, Suju. Great. Now we've understood this. Now the average time taken, let's say, is 600 seconds, right? So it is going to be 600 seconds. Let's say if the threshold was a little.
Sachin, this was through some experiment.
Yeah, yes. So yes, madam. So when initially the
so on a particular computer with a processing
correct.
Whatever, assume.
Yes. Yes, yes, madam. So that is the amount of time being taken, and we'll also see the actual, the list of transactions on the BTC website, and even a set of any 216 blocks that are getting created on the whole blockchain system. The average time, because it is taking 10 minutes per block. So it is going to roughly take 2016 blocks. 14 days is what that has been assessed, ma'am. So this is initially being assessed, and they are trying to keep it in that particular manner only, right? So that they are clear how many blocks will be created in how much amount of time, right? So they are trying to set the difficulty in a way that each block is taking 10 minutes of work. Right? So the question is right, that is it done by previous experiment? Yes, this based upon the previous setup and environment only, they have come to this conclusion. It's taking 2 weeks for generation of 2016 blocks. Thank you, ma'am. So now if we try to understand, like for example, average, I hope that was clear. Thank you. Now, if we see that each block is taking 600 seconds, but say if the threshold was little, higher, like very minutely higher, for each block, let's say the average time it took was 646 seconds, like 46 seconds higher, right? So now how do we adjust the threshold in a way that next time it tries to be closer to 600, right? So this is how it works. For example, the average time taken, this is a real case. We'll also see that example now, right? So there was one set of 2016 blocks taken, and the average time of generation of each block was 646 seconds. So now, because there was one specific threshold value, each of the it was actually taking 600 seconds, but if the threshold increased a little, then each of the block creation on average was taking 646 seconds. So now how do we adjust the new threshold so that again the system is at an equilibrium, like a normal state? So now this is the formula that comes up, right? So now the new threshold is going to be the current threshold into the average time taken by 600, right? So for example, I'm just going to explain this. Now the current time taken into average threshold is what, so we'll see this by example. Okay, so this will explain. So now, for example, the expected time that it should take for 2016 blocks was so and so many 2 weeks, which means 14 into 24 into 3600, so 3600 seconds. So this is going to be the actual time. So now add all the time taken for the creation of 2016 blocks. This is the actual time that took, which means T1, the time taken for creation of first block, second block, so and so up to time taken for 2016 blocks, right? So now this is the total time taken. Now, how is the average time taken? The average time taken divided by 2016, right? So this actual time, the actual time is the time, this correct time, right? So this is the actual formula that we have got. Now, from that, we understand the new threshold will be calculated in this particular way. The current time it is taking is 646 seconds into the average time a block is taking by 600. Right. So we'll see this in an example and it becomes a little clearer. Right. Right. Okay. So I'm just going to show the actual btc.com and I'll show you this. Right. So now if this is clear that the threshold gets adjusted based upon the current average time that is taking. If it is going higher, threshold will be adjusted so that it comes to the regular time that it is taking, right? So we do not want it to take higher every time, right? So there is some mechanism that should be there which will adjust the new t. The threshold has to be updated, right? So if you understood this, type U in the chat box. Thank you, Sujima. Yeah, so now Ishwaran sir has a question, which says, I see in website that there are mining pools. They have higher performing mining farms that will determine the threshold as they have more faster machines that mine with single ASCII machine. These questions are out of curiosity. Okay, so I think this was actually a question that was asked in the actual lecture also. There are definitely some systems, like if it's like a super performing system which is just built for this one algorithm and one purpose to just go and keep mining and try to generate hash value less than threshold every time. There are some systems like that. So in, like, let's just say in this 2016 blocks that are getting created, some of them are by the supercomputers which will be able to generate a block, let's just say, in lesser time. Okay. What is happening is definitely there is some advantage for them because they can test it faster and do multiple transactions. But the whole ecosystem, the whole system is set that in a way that the average time taken to keep it fair, the average time taken for a block to be created has to be 600 seconds or 10 minutes, roughly nearly to that. So Ishwaran sir, even if there is like a high performance, meaning that its hash rate is higher. But what we are trying to do here is set the difficulty and threshold for that particular set in a way that there's equal amount of fair mining and reward distribution should happen, right? Definitely there will be a little advantage for these PCs or supercomputers, but the system is trying to also be fair and also give equal amount of chance to perform some computers which are having a lesser hash rate also, right? So even we'll discuss about this as we go forward and how the system is trying to be fair. But thanks for bringing up that question, sir. Okay. So now we've understood that the threshold is always getting adjusted based upon the current threshold. Thank you so much, sir. Right. So we know that as the average time is increasing, whatever the current time is there, and we'll just multiply it into average time divided by 600 and we'll get the new threshold. We'll try to see this in action, right? Okay, so let's go ahead. Now, I'm just going to share one reference link. This also Professor Pandurangan sir explains in the actual lecture, right? So people who have joined just now or a little while ago, so this will be the teachable that you have access to. Now, currently we are in the module 7, right? So the revision is happening on the module 7. So do not worry if you have not able to log in also. I'll help you, or I'll share with you a video where you can go and do it by yourself. Okay. So you can start here and go access the lecture, right? So you can see that you'll be able to access the lecture from here. Okay, great. So if at all, right, so I've seen more people joining. If at all you've recently joined, do not worry, this hackathons happen in a cycle. The recordings of all of these are available. Will also come from the beginning once again, right? So that is not a problem. You can still start from the recording lecture. If at all you have any query, you can join the hackathon sessions and get your doubts clarified. So I'd encourage you to go ahead and start from the beginning, which will be from here, right? So you can start from here and proceed as each and every module gets completed, right? So I'm just going to share with you a link, which is this, btc.com/stats/diff, which is the difficulty, right? So we are going to see how, on an average, the difficulty was there previously, right? Okay, so I've just shared that link here. This will also be uploaded on your Teachable. Oh, okay. So Anveshak, it is Ravindra, sir. Sorry, sir. I've just seen the new name and I thought it's a new member. If you're not able to rename, let me go ahead. Thanks. Okay, so now you can see that the link has been shared. Now you can see the level of difficulty, right? So if you see the difficulty with respect to the time that happened, right? So this is difficulty with time, and this is the difficulties log scale. So now you can see that the difficulty was high and low, and it was varying based upon the average hash rate, right? So now if you see, there is the height. Height means, for the people who have recently joined, height is basically the size of the block. Like right now, at what position the block was created from the beginning. From if it is height is 5, meaning it is the 5th block. If the height is say 7,78,176, it is the number of block is that, right? So now if you see, each of these heights has a difference of 2016. Let's say I'm just going to calculate it here. 778,176 minus 776,160. So you can see that the value is 2016. Now you can see that the average block time creation has always been calculated for this set of 2016, right? So like Sujumam, you've asked, initially also it was calculated, and at every 26 to 2016 blocks, it is recalculated and threshold gets adjusted for whole of the new miners or new nodes, right? So I hope this is clear. So now if you understood that, the difficulties are always assessed in a set of 2016 blocks. If you understood that, type U in the chat box. Thank you, Sujana. Great. So now you can see that from the beginning, there are like every 2016, updates. So it is taken the new revised values, right? Okay. Ashish has a question. When a block is generated, how miners? Okay, so something is coming. Yeah. So when a block is generated, how miners are decided? They take only certain number of transactions in that block, because miners do not know each other, so they decide it. So basically, Ashish, like in our previous sessions also we have discussed, do not worry. So how this works is, now each transaction will have its own size, like, it will take so many bytes, right? And the block size of each block will hold a value of 1 MB, right? So whenever you're uploading, let's say some n number of transaction, you want to fit it less than that particular 1024 KB. So that is how, there's no set number of transactions that will be there. So for example, there are bigger transactions. The number of transactions that are getting uploaded into the block will be lesser, right? So for example, there's a smaller transaction, meaning for example, there's lesser inputs, lesser outputs in each transaction, which means the size of the transaction will be lesser, which means the block will have more number of transactions. So it is not decided by the miner on how many number of transactions that a person has to upload on the, validate onto a block. He'll be able to know that, in this particular bandwidth, because my transaction size is this much, this is how much it will fit. Right? So I hope that answers your question, Ashish.
In fact, in module 6, I guess, Pandurangan sir has shown the cases of one miner creating a block with a 303 transactions only, and another having 2000, almost 3000 transactions. But when it came to the reward, it is same amount, 6.2 BC. That means it is not really speaking, the miners don't look for the number of transactions, but valuable transactions, maybe the ones with the higher value of the transactions.
Completely true, ma'am. Thank you so much. I mean, I would also not be able to precisely put all of that into.
Yeah, all the transactions may not be the same. They of course, I guess they will look for the value of each transaction. Maybe that is why the reward amount was the same for both.
Correct. Thank you. Thank you so much, Suju ma'am. Right. So Ashish, I hope that answers your question also. Right. Ash says thank you. You can put it instead of direct message to everyone. So thank you so much, Suju ma'am. Great. I hope if this is clear for everyone also, type C in the chat box. Right. So how many transactions fit in, and it is variable, and the reward does not matter on the number of transactions you are uploading. So if you understood all of this, type C. If this is clear, type C in the chat box. Thank you. Thank you, Vijay. Thank you, Sushant. Thank you, Lakshman. Okay, so people who are joining us on our social channels, you can keep using the comment section. So I hope it is clear for everyone. Thank you so much. Yeah, so now coming to our difficulty and block height and the average transaction time that is taking for every 2016 block. Now we can see that there are actual stats always recorded for each of this set of blocks that is there. So now the difficulty kept on increasing. So initially, because there were less miners and less computational power, the hash rate was lesser, maybe the difficulty was less. But as it is, the time progressed, the difficulty kept on increasing. It's not like it is always increased. In totality, it increased, but keeps on fluctuating. Sometimes decreases, sometimes increases, right? So now how this is being decided, right? So how do we actually decide this? This is what we are trying to understand here, right? So now we're going to see what is covered in this, right? So the height of that particular set, then the block time when that first block in that particular height was created. So the difficulty is given here in T. We'll look at that as we proceed forward. Now if you see bits, now this bits is nothing but the threshold stored in hexa value. Now this 0x means it is a value denoted in hexadecimal, and this particular whole value, if you learned about exponent mantissa, we're going to just see that. So this hexadecimal value is stored here, and we'll also see what is the actual value in decimal. How do we translate that? Now, if you see from every previous block, there is some change. Like for example, if there is the change in difficulty, whenever there is the change in difficulty, for example, this was the new difficulty and this was the old difficulty, that difficulty is mentioned here and the change is also mentioned. So the difficulty increased by 9.95% here. Now, if you see here, this here, because roughly it was less than 10 minutes, the difficulty did not change much here, right? So that is all of this has been recorded and all of that is graphed here, and I've shared the link also on chat, right? So now you can see that average block creation time in the whole of that particular set was 9 minutes 6 seconds, right? This is the recent block. Now, if you see, everything is roughly around 10 minutes. Now, if it is taking lesser than 10 minutes, more or less, it is not heavily adjusted, but whenever it is going higher than 10 minutes, it is getting adjusted again. Right? So now you can always see that. Right? So whenever it is less, difficulty is just slightly being adjusted. Whenever it is more, the difficulty is, slightly reduced. Right. So now this is what we've understood overall from here. And the average hash rate also is mentioned. We're not going to discuss heavily on that, but the average hash rate for that set of miners or nodes was so and so value. Now you can see that the average hash rate as years progress, like 2020, it was different. Now today we are roughly talking about twice or roughly more than that, the hash rate, right? So we are seeing that change. So now this gives us a rough idea of how the threshold is getting adjusted when new blocks are getting created. So now in this, we are going to see this one example which Professor Pandurangan sir explains. I'm also going to give that number here, which is this, okay, 6,768,000. I'm just giving the value here. Now this particular value, if you opened it on your system, that is fine, or else you can see here. Now this is one particular value. We'll see more of the details in our upcoming session also, but now if you see, I will try to decode this. The threshold that was given, like the T value, is 171480 DF, right? So it is in hexadecimal, 8 bytes. So for that reason, it is here in this format. And the time taken for average of each block was 9 minutes 31 seconds, right? So this was the difficulty. Now we come to our slides. Now this is the link that professor will share in the session which I have shared with you. Now 6,768,000 is the transaction that we're talking about, and the difficulty is this 17148 EDF. This is actually a value for the people who are like first time joining. We also have discussed on how to convert from hexadecimal to decimal to different numbering systems. So it is just a value represented or stored in a different format, which is hexa format, right? So which will make it easy for us to compress and write it on an easier way, right? So now we have seen that it took how much time here. It for this particular block, it took roughly so the set of all of this block, the time is updated here, right? So what time it took? It took 10 minutes 46 seconds. Now you can see that, which was 646 seconds, right? So now if slightly increase in threshold, so that miners find the nonce little earlier. Now because what we have seen is because it is taking higher than 10 minutes, if we just increase this threshold slightly, what is going to happen? The miners will find the nonce a little earlier, and basically we are reducing the time for them to mine, right? So because the system is doing this in a automatic format, right? So now coming by our formula. So first we'll try to understand the new transaction, new threshold value, right? So we'll try to decode that. So every time based upon this formula that we have seen, which is the new threshold value will be the current threshold value into the average time by 600. So this is what we have figured out. Now, if at all we try to do that, so what is the current threshold value? The current threshold value is this, which is 171480 DF. So now we need to set a new threshold value, which is 171620 D1. So the new threshold value equal to the current threshold value into the average time it took by 600, right? So now is everybody clearly able to see how the new threshold value is getting created? Now out of all this, the threshold value is the the tab, right? So if you make it tighter, looser, and based upon that, all of the values are changing, right? So now if you see that the control is here, the new threshold value is getting calculated on after a set of 2016 blocks. Now if you have seen this, the new threshold value is this, which was calculated based upon the previous threshold value. So the formula is this: the new threshold value has been calculated based upon the current threshold value into the average time, which was 646 divided by 600, right? So if you understood this, type U in the chat box. Great. Thank you, Sujima. Thank you, Prashant. Thank you, Vijay. So people who are joining us on the social channels, thanks for sharing. Okay. Now we have understood this. Now let us try to understand, like, because try to make it in a numerical format, this particular hexadecimal. Now, just to understand like how these numbers are calculated, there is something called the exponent mantissa format. Like, for example, I'm just going to give you the concept of it. This is in binary. Do not worry about the numbers. Whenever there is a number that is represented, let's just say this example. I'm just giving you a random example. Don't go by numbers. So the initial portions of it is taken as exponent, and then the rest of it is the actual number. Meaning now, because we're talking about the exponent here, the value. Okay, sorry, I did not add that screenshot. Give me a second. Okay, so now if you see this 171480DF, in that this 17 is going to be calculated in this, like used in this particular format. Now, because we are talking in terms of the exponents of 256, it is going to be calculated as the exponent value. Now, 17 in hexadecimal format is written as 1 into 16, this particular 1 into 16 plus 7, which is going to be 23, right? So because we are talking in terms of 256, the actual exponent is coming to 256 power the value that we have calculated, right? So what this value means is we're going to cover more of this detail in our upcoming session also. So do not worry about the calculation part, but try to understand in the scope of this particular session is the threshold value is the new threshold value is getting calculated based upon the previous threshold value multiplied by average rate divided by 600. So if we understood that, it is probably enough for this system, this particular session. To next upcoming session, we're also going to understand more about it, right? So just a little more insight is each of this value is, the first initial portions of it is the exponent multiplied by the whole value. Because now if you see the threshold value, if you have seen 1 and threshold value is being t and 2 power 256, the threshold value could be so high, right? So it could be in some multi-digit number, right? So it could be in crores of crores. So if that high number in hexadecimal will not be able to represent in this format, right? In this, such a small number will not be able to do that. So now what is happening is this first initial 17 is going to be the exponent. So 2 to the power of that expression, that value that is coming, and this is going to be the actual number, right? So for example, if you're talking about this case alone, so what is happening is, okay, sorry, this difficulty, what professor has done here is he has taken, consider the 17 as exponent, it is going to be 256 power, the hexadecimal, the decimal value of this multiplied by this whole value, which becomes a very large number, right? So 2 to 256 power, let's just say 20 also into the actual decimal conversion of this, right? So now for example, 148 EDF, this is the actual hex number, and 17 was the exponent. To 256 power of that exponent will come. Now if you convert this into decimal, this is the actual number. Now, which means the total number, I'm just going to write it here. We'll cover more of this in our upcoming session. So the whole total value is going to be this numeric decimal conversion of this hexa, right? Okay, I should have done this before. I'll just write it here. Okay. Now this is in hexa and this is in decimal, and the 17 that was there, which which was there, that is going to be converted into the exponent, the power like this, 256 to the power of, okay, in decimal format, 20. right? So we'll cover more of this understanding in our upcoming session. But this will be the whole bigger value. The threshold value is going to be 256 power 20, which is in itself a large number, into 1347295, which is even large, right? So this is how the threshold value is getting calculated, and the new threshold value is getting calculated based upon the previous threshold value. So I am just trying to give you the sense here of how big the threshold value is, right? So we are not trying to calculate the threshold here. I'm just telling you this threshold value that they have given is very huge. So 256 power an exponent multiplied by the decimal conversion of this hexa format, right? So now you can understand this threshold is going to be a very huge value, right? So just 2 to the power of, our regular numbers like 2 to the power of 10 itself is going to be 1024, or like, that when you go into that binary, exponential format is going to be heavy, right? So now 256 power 20 is going to be very large, and multiplied by this decimal value is even going to be higher. So the threshold value is calculated and saved in this particular format. So now if you understood how the threshold value is saved in this particular sheet, and if you are able to know that how high this value could be, if you understood all of that, type U in the chat box. If this is, understood, type U in the chat box. Thank you, Sujam. Thank you, Vijay. Thank you, Rachna. Okay, so this brings us to the conclusion of this particular, module. A little of it remains, which we will cover in the upcoming module. So basically, the blockchain revision hackathon happens on Tuesdays and Thursdays. So the upcoming Thursday, we're also going to see more of this concept and also try to appreciate on how the new threshold is being adjusted, making it easy or difficult to the whole of the miner community, so that they comply to the actual set time decided while creation of the system, right? So I hope the session was valuable. If there are any other questions apart from what we have discussed here, you can let me know. If everything is clear, type C in the chat box. The overall, if overall is clear, type C in the chat box. Thank you, Sujama. Okay, so I hope this was clear. And the people who have recently joined, if you briefly parts of it, if you understood that, type U in the chat box, right? If at all you've not understood most of it also, do not worry. There will be revisions, hackathons that are happening, in a cyclic fashion. Even not, I request you to go from the beginning and, go step by step, right? Yes, Prashant. So my name is Sachi, just sharing it here. Thank you so much. Yeah. Thanks. Thank you so much, sir. Happy Holi to everyone. Thank you so much, Rahul sir, for bringing in, right? Thank you. Thank you so much. Happy Holi to you too. Have a very good one. Yeah, so Prashant, there'll be a session. Thank you for reminding it. Okay, so the session reminder might have reached your email. So Prashant, did this session's reminder reach your email? Yeah, so in that case, I request you to just search for j@pixeltest.com. Might get into your updates or something. You can mark it into your primary, right? So the session will be at 8 p.m. We'll also send a reminder just before that, right? So you can join there. A little introduction on how the system is, how to access your teachable, and how to have a good system for you to complete the course. All of this will be taken by JN sir, and a little more other things also. Great. I request everyone who has recently joined also be there. Okay. Yes. Yes, Suju. Yeah, and Suju, we also have a few members from our AI who are completing the certification. So we are going to have the Hall of Fame of that also in our. So it's like because you enjoyed the hot seat previously, so this will also be interesting, I feel. Okay. Thank you so much, everyone. And yeah, great. Thanks for your patience and looking forward for our upcoming Thursday session. Great.